everyone, welcome to SchoolQuizz. So this side, Anjali Singh, and we will meeting again with the new numerical. So last day we studied the numerical that is based on the second law of motion. Okay, so today we'll do the next numerical. Okay, I'll again share the PDF. Yes, now this is the time to do the next numerical. A force of mass 5 Newton. Force is given already 5 Newton. Every time student, first you have to make the list of given quantity, whatsoever given to you. 5 Newton. Okay, given a mass m1. Okay, so the mass is given m1 and acceleration is 8 meter per second square. And the mass m2 for the next, this is for the, I think this is for the first quantity. For the second, mass is given m2 and acceleration is 24 meter per second square. What acceleration would it give if both the mass are tied together? So student, yes, when both the mass are tied together, what you have to do? So the first mass m is equals to m1 is equals to f by a, because f is equals to ma. So f is given what? 5 by 8. So it will be 0.625 kg. That is m1. Now for the second, F remains same 5 Newton. Mass will be m2. So we have to use F is equals to ma, mass is m2. Acceleration is also given, that is 24. So 24 m2. F is given what? Okay. So F is given 5 Newton. It remains same for the second case also. So the m2 is 5 by 24 kg. This is the first mass. This is the second mass. Clear? So the mass will be, if you are going to divide, so you will get this value, 0.208. I think that's clear to you. Clear? Okay, that's clear to you. Now, you have to find the again acceleration. That's really easy. F is equals to ma. A is equals to again F by m. So the F is 5. That's given in the question for both the cases. Okay, mass is 0.833. Okay, that we will find from here. How? You will get this mass and you will get this mass. That will be 0.208. Here it is written, both the mass are tied together. It means both the masses, you have to add both the masses. So you add it and you get this. So the acceleration you will find F by m. Okay, sorry, F by m. So that will be 5 by 0.833. And you will get here it is given 6 meter per second square. So here what is the clue? The clue is both the masses are tied together. So you have to find the first mass. Like that you have to use find the second mass also. Okay. Second mass also. And you have to add both the masses and then you have to find the value of acceleration. Clear everyone? Okay. Okay. I'll I have to erase because that's not looking fine. So yes, for the second, I'll solve you verbally. What would require a greater force accelerating a 100-gram mass? Mass is given 100 gram at 5 meter per second square acceleration, or 20 gram. Okay, you have to compare 20 gram mass at 2 meter per second square acceleration. Yes, you have to find the value of acceleration. Okay, greater force. So you have to find the value of force. What you have to do? You have to find the value of force. So the force is equals to MA. Do this. Gram has to be converted into kg. So you did this. Next, again you did this. So the greater force will be, what's the value you will get? So you have to just compare. Here you will get the greater force, because here the force will be greater. Clear? Here you will get the greater force. I think that's clear to you. So like that, our second law is over. We completed first law as well as we completed the second law also. Now it's time to start the third law. That's really, really interesting, because that you are using every day, every time. What third law is saying? Third law is saying, I'm not directly jumping into the statement. I'll explain you with the help of some basics example which you are experiencing in day-to-day life. Here you can see, if a boy wearing roller skates, okay, so stands facing a wall and pushes the wall with his hands. So he started pushing the wall. The boy finds himself moving backward after he pushes the wall. So what he finds? He also moving backward. In this case also you can see this is moving backward. He exerting force on the wall. I think the wall is also exerting force on the boy. That is why whatsoever force is exerted by this boy to the wall, same force is exerted by this wall to the boy. Clear? Here the boy is exerting a force, some amount of force, some Newton amount of force on this wall, and the wall is also exerting force on this man. Clear? So this is the action force. This is the action force what this boy is exerting on the wall, and the reaction force which the wall is exerting on this boy. Clear? This wall is exerting on this boy. That is only written in this here. And if you are thinking this boy is wore this rolling skate, that is why, no. If he hasn't wore anything, then also there will be an action force and there will be a reaction force. Okay, and these both action and reaction. Okay, I have to use this force, this action and the reaction force are always equal, Clear? And they both are acting in, okay, both are acting in different body. Okay, they both are acting in different body. They cannot act in same body like the boy. No, it has to be another object also. Clear? From this discussion, we conclude that when a boy exerts a force on the wall exerts an equal and opposite force. This is known as reaction force. Reaction force is equal and opposite force. Clear? Which is equal to the action force. Okay? I think that's clear to you. Yeah, I have to rub this, then everyone please note down all this. That's important. Now you can see, yes, when a body is influenced another body by applying force. Say that the first body is interacting with the second body. Okay, whenever the two bodies are interacting, it means they are exerting some force on each other. So the one force will be the action force and the another force will be the reaction force. Clear? Okay? Yeah. So then now, according to the Newton's law, okay, what happened in it? So now you can see whenever one body exert a force on another body, the second body exert an equal and opposite force on the first body. It means it's compulsory. When you will push the wall, sometimes as student or the person who is angry, so what they are doing, they are just pushing the wall. Okay, what they are doing, they are just pushing the wall and they just give the punch on the wall. So what happened? They just punch on the wall, and this they will also feel pain on this side. Why they will also feel pain on this side? Because there will be a reaction force that wall is exerting on the person. Clear? So this is the third law. Third law is, to every action there is equal and opposite reaction. I'll mark it so that you will also write this. This is the statement of the second law. For every action, there is always an equal and opposite reaction. Clear? This is the third law. This is experimentally. Yes, here the man is exerting force on the cow, but the cow is exerting an equal force on the backside. Okay, so they both are exerting force on each other. It means Newton's law. Clear? It means what it will be? It will be Newton's law. Let's see. In case of spring also, when you will see, this is spring balance. So when what you'll see here, two spring balance are here. When you'll apply the force on this spring balance, simultaneously the spring balance is applying force on you. They both are always equal and opposite. That is clear from the Newtons. That is cleared as well as experimented. The same force will be exerted by the object on you also, whatsoever you, and that will always be an equal force. Clear? We concluded that the action and reaction force are equal in magnitude. Equal in magnitude. Suppose you applied 4 Newton force on the wall. The wall will also apply 4 Newton force on you. But their direction is opposite. Toward east, toward west. Action and reaction force act in opposite direction. Action and reaction force is always acting in opposite direction. Clear? I think that's clear to you. Okay? To understood, for more understanding, we'll see action and reaction and act in two different body. It's like, the boss exert action on the ground and the ground exert an equal and opposite reaction force on the box. Suppose this box, this is the box, and it is kept on the ground. This is the box and this is kept on the ground. So what will happen? This will act force on this ground. And the ground is also exerting force on the box. So this force which is acting, the force which is acting on the downside, this will be action and it is the weight of this box. And the force which is acting on the upside, so that will be the reaction force. That will be the reaction force. Clear, everyone? Action force means the force acting on the downside, and the reaction force which is acting on the upside. They are always equal. Okay. Till now, Okay, till you applied an external force on it. If you apply external force on it, so this will be different. Clear? This will be changed. Now, after that, the scenario will get changed. Some more examples. I will erase this. It's not looking good. Yes. Sorry. Some more examples like, how do we walk? We'll exert this upward leg on the forward side and this backward leg, okay, in the backward side. So this will act as a action. Means we are exerting force on the ground. We are exerting force on the ground with the help of our this backward leg. Like that, same force is acting by this leg on this upward. Okay, in this forward side. Clear? This will be acting forward side. Like that, we are able to walk on the ground. Here also, yeah, it is difficult to walk on a slippery ground because why? Like ice or like, yeah, slippery surface like tiles. Why? Because here we are applying force, like the same force is applying by on us. Here also, swimmer. Yeah, it push of swimmer on water. Water also pushes the swimmer. Okay, this will be, yeah, here you can see with this hand, the swimmer pushing backward, and with this hand, it is moving forward. With this hand, the swimmer is pushing, this girl is pushing herself in backward direction, and from this hand, this girl is pushing herself in the forward direction. So clear? Here, same formula is applying. Action is just equal to the reaction. So I think that is clear to you. Okay, we will discuss more concept based on that, but in the next class. I think that is clear to you. The acceleration produced will be more in the body having the less mass, that you know, because F is equals to ma. Mass will be less, acceleration will be more. Acceleration will be less when the mass will be more. So they are inversely proportional to each other. Now, the next question arises, why the gun recoils? Okay, that we will discuss later in the next class. Okay, till now, I think you cleared with the topic. What is Newton's third law? Illustration of the Newton's third law. Okay, now you are able to apply, or you able to understand how Newton's law applies in your day-to-day activities. Okay, students. So till then, bye-bye.